Okay, here we go. Number 11. This video will contain the problems 11 through 20 for the 4.1, 4.2 review for secondary math 3. So, number 11 says use the properties of radicals to simplify the expression. So the main thing you need to know is this. This has multiplication, and when we multiply, we can only multiply if root sizes are the same. Okay, and since they are the same, then we just multiply the inside. So we get the fourth root of 6 times the fourth root of 8 equals the fourth root of 6 times 8. Okay, and since it doesn't say using a calculator, I can't just type that in and figure out what it is. It doesn't want a decimal. What it wants you to do is break things out and simplify by finding groups of 4 because our root size is size 4. So 6 is 2 times 3, and 8 is 2 times 4, and 4 is 2 times 2. Do you see how I have 4 different 2's in there? Since I have 4 of those, I can bring them outside of the root, and whatever's left, which is this 3, has to stay in. So that is the simplified best answer. Okay? It doesn't say using a calculator, so if I plug that into my calculator, I'd get this decimal, and it doesn't want a decimal, so I have to do the exact answer by simplifying the root. Okay? So, with this one, it says write the expression in simplest form. So, a couple things. Some of you might think, let's just divide it and see how it goes. A couple things you could do. You could write it as 1, but then you do 5 divided by 4 and you get some decimal. So that doesn't help. We don't want decimals, okay? So we're going to leave it as the cube root of 5 over the cube root of 4. And this is the dividing of radicals and the math people picky way of saying we don't like to divide by a root, okay? So I've got to get rid of the root on the bottom. So what I need to understand is 4 is 2 times 2, but since my root size is 3, I would like to have 3 of those. So I'm going to give it another one by multiplying by the square root of 2 on bottom. The cube root of 2, and the cube root of 2 on top. That way, I have 3 2's, and my bottom is now just a 2 with nothing left on the inside. And then my top becomes the cube root of 5 times 2, or 10. Okay, and remember, we can't simplify anything on the inside with anything on the outside. So insides with insides, outsides with outsides. And we have nothing left on the inside on the bottom of this fraction. So that's as far as we can go. Okay? 13 says simplify. If I have 3 times, or 3 11s to the 4th roots plus 9 11 to the 4th roots, okay? These are yucky. I get it, okay? But if I just replace those with something else, like $3 plus $9, you'd be like, Miss Bustle, this is easy. $12, right? Or whatever. I know that's backwards. But instead of using that, we have 3 of these ugly 11 to the 1/4 power plus 9 to the ugly 11 to the 1/4 power is going to give me 12 11s. I don't know why it's doing that. 12 11 to the 1/4 power. Don't try to get crazy. Don't try to combine things. Okay, it's addition, so we're going to add them. Okay, and we can only add them if the things are the same, if the bases are the same and the root size is the same. Okay, here's 14. Use the properties of radicals to simplify the expression. So unlike the other one where we want to just get rid of the thing on the bottom, if you notice 2 and 486, they're both even. So this one, it would benefit us to write them as one root and figure out what 486 divided by 2 is, because I know it's not going to be a decimal. And this is the same thing as the 5th root of 243. Okay? And I'm going to see it, 243. we might be able to use our calculator, or I know we can simplify it by hand by trying to find 5 of the same number. So 243, I know that 2 doesn't go into it, so I'm going to try 3. So I'm going to go 243, divide that by 3. Oh, and I get 81. 3 and 81. And 81 I can work with because I know my times tables. 9 times 9, which is 3 times 3, and 3 times 3. If you notice, I've got 1 3, 2 3s, 3 3s, 4 3s, 5 3s, and nothing left over. So my answer is going to be 3. Okay? You could also go 243 raised to the 1/5, okay? And you would get 3. But just know if you get a decimal on that, when you try that, it doesn't want a decimal, so you're going to have to simplify by hand, okay? 15 is very similar in that fact, except for we're going to go backwards. 3 divided by 8 is going to give me a decimal. And I don't want a decimal on the inside, so I'm going to separate it. Okay? And we want 2 things, okay? But right now I have 2 times 4, which is 2 times 2. I have 3 things. So these guys I can take out, but I still have a 2 left in. So I have the root 3 over 2 square roots of 2, because this guy's left on the inside. And now I only have 1 2 in there. So I'm going to give it another 2 on the bottom and another 2, or give it a 2 on the top. And I get 3 times 2 is the square root of 6 over 2 on the outside. And then I can multiply by another 2 because these guys will no longer be roots. And I get the square root of 6 over 4. And I'm done. Okay, and I can't simplify the 6 and the 4, even though you want to, because they're both even and you think you can. Okay, but the 6 is on the inside and the 4 is on the outside of a root, so we cannot. Okay. 16. 16 is a little bit different in the fact that you have addition going on the bottom. And we don't like roots on the bottom, but we definitely don't like addition of roots on the bottom. So if you remember, we have this thing where we can multiply by a conjugate. And a conjugate, I'll write it down, conjugate, okay? All it does is you have, the conjugate is where you just change the middle sign, okay? So we are going to take this guy and we are going to multiply it. I'm going to rewrite it. We are going to multiply the top and the bottom by the conjugate of the bottom, okay? And you're going to see some beautiful things happen. Well, maybe you don't think it's beautiful, but some cool things will happen when we do this. So if I multiply the top, I'm going to distribute. And remember, outside stay on the outside. So that's just 9 square roots of 3. And that's going to be minus 9 square roots of 7. Okay? But on bottom, it's going to be awesome. So we have root 3 times root 3. Well, that's root 3 times 3, okay, which ends up being just 3. Okay with that? Because there's 2 3s on the inside. Then we have minus square root of 7 times 3, which is square root of 21. Okay. Then we have positive root 7 times positive root 3. So I have plus 7 times 3, and I get plus square root of 21. And then the last one, I have positive root 7 times negative root 7. I get minus square root of 7 times 7, or minus 7. And this is why the conjugate is awesome, because you have the 2 middle terms, the minus root 21 and the plus 2 root 21, will always cancel. Okay? So right now, we have our top as 9 square root of 3 minus 9 square root of 7. We can't combine those because the square root of 3 and the square root of 7 are not the same thing. But on bottom, now I have the 3 minus 7, which is now 9 square roots of 3 minus 9 square roots of 7. Top stays the same. 3 minus 7 is negative 4. Okay, you can write it that way. Sometimes people don't like negatives on the bottom. If you don't like negatives on the bottom, you can say negative 9 square roots of 3 plus 9 square roots of 7 over positive 4, where you just change the signs. But this is the correct answer. Pause, take a second if you need it. Okay, I'm going to continue. Simplify the expression. That means we're going to pull things out. Pull stuff out. Okay, and we pull stuff out in root sizes. Okay, so right now, 81, I'm looking for groups of 4. So 81 is 9 times 9, which is 3 times 3 times 3 times 3. These can come out all together. There's no number left on the inside, so I'm going to write that. 3 on the outside. Then y to the 8th. Y. There's a group of 4. And then I have y. There's a group of 4. I've used all 8 y's. So 3 times a group of y times another group of y. Nothing left on the inside gives me the answer of 3y squared. Okay. 18 is a little bit different. Same idea, except for everything's not going to be nice and beautiful. So simplest form, same thing. We're looking for root. And some people are like, Miss Bustle, I don't know what root size that is. That's the square root. If you were to read that, that's the square root. And we represent square by a 2. So 81, 9 and 9. Some people are like, you got to keep going. Once I have 2, stop. Why would I break them down further? Okay. And then we have a to the 7th. And I could sit here and write out a's. Okay. 7 a's and circle them in groups of 2. Or I know that I can have an a cubed and an a cubed. That's 6 a's. And then I have 1 a left over. Right? Okay, because 7 divided by 2 is 3. The most you can do is 3, and you have 1 left over. Same with this b to the 12th. 12 divided by 2 is b to the 6. So I have b to the 6 and b to the 6. There's my group. Okay? And then we have c to the 9th. C to the 9th into 2 groups. I get c to the 4th, c to the 4th, and I have 1 c left over. So when I write this, the 9 comes out, the a cubed comes out, the b to the 6 comes out, and the c to the 4th comes out. But what's left inside? Well, this a and this c. Everything else got to come outside because it had a partner with the square root. It wasn't a group of 2. Okay? 19 says use the properties of rational exponents to simplify. So remember, when we have something on the outside, an exponent on the outside, it's going to distribute to everything on the inside. So I have 5 to the 1/2 times negative 1/4 times 5 to the negative 3/2 times negative 1/4. And we're not super good at our fractions, but we're going to figure it out, okay, because I showed you. I'm not going to worry about the 5s, but I'm going to do the fraction work. Do 1 divided by 2 times negative 1 divided by 4. And you're like, what the heck is that? You get a decimal. I don't want decimals, but we're going to push this math button, change it to a fraction, and I get 5 to negative 1/8. I'm going to do the same thing with the next one. Negative 3 divided by 2 times negative 1 divided by 4. I'm going to figure out what that fraction is. And I get 5 to the 3/8. Okay? So now it's simplified. And then now, if you look at your rules, if you're multiplying things with the same base, you add the exponents. So we get 5 to negative 1/8 plus 3/8. You can do that in your calculator too. We go negative 1/8 plus 3/8. And you're like, what the heck is that? Well, math, fraction, that equals 5 to the 1/4. Boom. Okay, last problem on this video, very similar to the other one. Remember, we're looking for groups of 3, and we're going to take groups of 3 out. So 125 is 5 times 25, which is 5 times 5. Here come my 5s. 5s are out. There's no numbers left. Then r to the 4th, I'm going to be able to make one group of r cubed, and I have one left over. So they come out as an r, right? And if it helps you, you go r, 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 r. I don't care if you write it 4 times. You got 3 and 1 left over. Then s to the 9. You're going to be able to make 3 different groups because 9 divided by 3 is 3. So you're going to do s cubed, s cubed. That's 3 9s, so we get s cubed. And then t to the 7th. If it helps when it doesn't divide evenly, just write them out. 4, 5, 6, 7. And then groups of 3. I got one group of 3, 2 groups of 3, so I have t squared. So the only thing that I have left inside this root is I have an r, because I had 4 and 3 of them, took 3 of them out, so I had 1 left over, and a t because I had 7, I took 6 of them out, and I had 1 left over. Okay, those problems can get complicated. Don't get like too nervous about them. You did them a lot last year. I think it'll come back to you pretty easily. If it helps you, well, not if it helps you, but make sure you have to show work on these, you guys. You can't just like hope and pray that it's going to come to you. Write stuff down. Like for this problem, I wouldn't even care if you wrote it, like this is going to seem really extra, but I don't even care if you write it as like 125 RRRR SSSSSSS 2, 3, 4, 8, 9, and then 7 T's. T, 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 T. I think that's 7. And then you started going in groups of 3. Okay. I'm okay if you do that. That's not like a horrible thing to do, but you've got to show your work on these. You won't get credit if you don't, but you also will have no idea what you're doing if you just try to like hope that it comes to you. Okay. One more video shows you 21 through 30. Keep working hard. You've got this.